This is heat transfer, and in this lecture we're talking about chapter 12 and starting chapter 13. We will start this lecture by going over sections 12.6 through 12.9. The first topic that we want to discuss today is response to surface irradiation. We already know what emission is, and we already know what emissivity is, and now we want to talk about irradiation. We also know what irradiation is. It is incident radiation on a surface. Now we want to talk about what actually happens to irradiation or radiation that is incident on a surface. We generally say that when you do have irradiation, what happens to the radiation that comes to the surface is three things could happen. It could be reflected back towards other surfaces, it could be absorbed by the surface, or it could be transmitted by the surface. If you take a look at the figure, we have, for example, G for irradiation. G at a given wavelength lambda is either reflected, that gives you G lambda REF, REF for reflection, or you could have G lambda ABS for absorption, or you could have G lambda TR for transmission. From first law of thermodynamics, we know that energy arriving at a surface, it has to go to different ways, but it can't get destroyed. So we generally say that the energy, the radiation energy that comes to the surface, it's either reflected or absorbed or transmitted. It's the total irradiation on the surface is equal to the sum of the reflection, absorption, and transmission cases. You could have all the three cases, or you could have only one or two of them. For example, for black body, all the radiation on the surface will be absorbed. Black body by nature absorbs all the radiation or all the incident radiation on its surface. None of that radiation will be reflected back to other surfaces, or it will not be transmitting radiation. So now we want to see what happens with an opaque material when irradiation happens on its surface, or when there's incident radiation on its surface. We know that for an opaque material, radiation cannot go through the material, or it cannot be transmitted through the material. So in that case, part of the radiation can be reflected and part of it can be absorbed. There's no G or irradiation due to transmission. Then question is, how about glass and water? Are they considered semi-transparent or opaque? This is an interesting question, because usually people think that glass and water are actually semi-transparent because you actually see visible light going through glass or water, but that's only visible light at the wavelengths related to the visible light. A lot of radiation is not visible light, and some of the wavelengths of radiation, glass and water may actually act like an opaque material. In other words, radiation cannot get transmitted through glass and water for some wavelengths of radiation. So you have to really be careful at what wavelengths you're doing your analysis. Now, an interesting point here. Unless an opaque material is at a sufficiently high temperature to emit visible radiation, its color is determined by the spectral dependence of reflection in response to visible irradiation. What do we mean by that? In some cases, some material get to a temperature where they do emit radiation in the visible light region or in the visible light wavelength because of their temperatures. In those cases, the emission is because of their high temperature and they look red. Or when you see something, a metal that's very, very hot, they say it's red hot. That's because of its very high temperature. It's actually emitting radiation at the wavelength that's related to the color red. But then in most of the cases, if you see an object that is actually red and it's at normal room temperature, the reason that it appears red to you is not because of its temperature. It's actually because of the irradiation or incident visible light that occurs on its surface, and some of that irradiation is absorbed by the surface and some of it gets reflected. What parts of that incident light that gets to the surface gets absorbed, and what parts gets reflected depends on the pigments on the surface. For example, if you have a red surface, the pigmentation on the surface is in a way that the part of the red incident light gets reflected, and the rest of them, like yellow, green, and blue, they get absorbed. So that's how, because the red part of the light gets reflected to your eyes, you actually see it as red. Same goes with leaves that are actually green. It's because of the pigments of chlorophyll on the leaves that reflects green but absorbs everything else like yellow, blue, and red. And then there are surfaces like white and black surfaces. White surfaces are those that reflect everything, all the different parts of incident light or incident visible light. And as a result, they appear white to you. When everything gets reflected, it appears white. And then when nothing gets reflected, nothing gets reflected to your eye, so you don't see anything, and that's how things look like black. So when you do see something like black, it's because there is no reflection to your eyes, there is no color reflection to your eyes, so it appears as black. So it's your perception of that object that's black, but basically there is no reflection from that object to your eyes.